welcome to our webinar. Today we're going to be talking about how you can reduce homogenizer water use and ultimately save money with our Homogenizer water recycling system, or HWRS. Let me start by introducing myself. My name is Con O'Driscoll. I'm a product manager for dispersion products here at SPX FLOW. I'm based in England and I'm very excited to share this product innovation with you today. Let's also just talk through a few housekeeping rules for this webinar. The presentation is being recorded, and that enables us to send you a link to the recording afterwards in case you're not able to join some or all of the presentation. Your camera and audio has been turned off. However, you can chat and ask questions through the chat and Q&A boxes on the presentation. And feel free to submit questions as we go through. I'll take some time at the end of the presentation to answer those questions and follow up subsequently if I'm not able to answer them or don't have enough time. And finally, as you leave the webinar today, you'll be invited to take a short survey. I really encourage you to help us by taking that survey. It's only a few questions, but it does give us the opportunity to make improvements on our future presentations and product launches. Thank you. So let's move to the agenda and the items we'll be covering in relation to the HWRS. After an introduction, then we look at what the Homogenizer water recycling system is, how it works, the key benefits, and how it can be implemented in homogenizers and different plants. Most of you will know what an homogenizer is, but let's just take a quick look at the basics to remind ourselves. And essentially, an homogenizer is a positive displacement reciprocating pump. See some images here, typically with 3 or 5 plungers. And the pump is driven from an electric motor through a gear and crank with a V-belt typically. And that rotating movement of the crank is converted to the connecting rod and crosshead connections in a linear plunger movement. So the combination of the transmission oil, which is collecting heat that requires cooling with water, plus the plungers need lubrication and cooling. Those combinations mean that homogenizers can typically use quite a lot of water to operate well and remain cool. But how much water do homogenizers use? And this is often underestimated. Typically, an homogenizer is quite a large user of water, and I've made a summary on this table here using general size designations of small to extra large, and then other covering older machines or extra large, additional large machines. And the typical water consumption of the different sizes ranges from just under 1 gallon per minute to over 5 gallons per minute. And then on the right-hand side of the table here, taking the example of either 10 operating hours per day, 6 days a week, 50 weeks a year, or 20 operating hours per day, showing some examples of how that water consumption can really start to add up. So we look at the 20 hours a day column. You can see that when you get to medium, large, and older homogenizers, you can quickly be looking at from 500,000 to almost 2 million gallons of water consumed. So there's a lot of opportunity to think about how we can save that water and reduce it. So what is the HWRS? Let's take a look. This is a new innovation from SPX FLOW, which is really built around conserving one of nature's most valuable resources. It's a groundbreaking water technology exclusive to SPX FLOW, and there's nothing quite like this on the market. We'll take a little look further on at how it works and why that is so. It's important to remember that this fits any brand homogenizer, not just SPX FLOW homogenizers. And the key benefits of this new technology summarized here: sustainability in terms of water and cost-saving opportunities, the integrity of the water that's recycled in terms of water quality, and also the uninterrupted operation of the plant. And then it's a plug-and-play system, so it's compact, it's automated, it's ready to install with minimal integration. I wanted to just share some thoughts on why now? Why is water saving important? And a number of factors which we've seen, and that you may have some others as well. Firstly, producers are looking for ways to reduce their water footprint in their component and systems, and that can be driven by cost or sustainability or a combination of both. We also know that water stress and awareness of water consumption is increasing globally, and water costs are increasing both through extraction and waste disposal. In process plants, homogenizers and many other items of process equipment can use clean water for cooling and lubrication. And unfortunately, that water is typically used once and then disposed of as part of the wastewater stream. And traditional waste treatment systems are based on large-scale utility plants requiring complex recovery and distribution processes. I think you've probably all seen when you've gone into a process room, there can be water flowing out of various places on the floor, going down the drain, often unchecked because people have got used to a certain level of consumption of water in the past, perhaps, and opportunities to save water haven't been readily available. Remember that a single homogenizer consume more than 5 gallons per minute of water every minute of the day that they're running. So why are these factors now different? And as we see it, and summarizing here, where we have different drivers to save water, whether it's cost, whether it's water availability, whether it's the water consumption itself, because perhaps a plant is running on longer hours, increasing production, or whether it's sustainability, whether a local, site-driven, corporate, or national target. All of these factors come together, and we see the HWRS system as being beneficial when several of these factors, if not all of them, are driving a producer to look at their water footprint and discover ways to reduce it. HWRS brings us that, and it allows the water to be recycled, enabling the reduction of 97% of the consumption of the homogenizer. So a summary of what it is, and then we'll talk about how it works. So it's a plug-and-play system which integrates to the homogenizer water supply. The system's designed to recycle 97% of the water in a closed loop sensing and sanitizing arrangement. It's fully automatic with simple user interface. The water quality is certified to PMO standard for process use. The payback will depend on a number of factors, typically the water cost and water consumption. And the system can be used on any homogenizer, not just APV models. The capacity of the system is designed for optimal benefit on medium to large homogenizers in continuous process lines. And that's really about scaling the technology for maximum benefit and not on small or infrequently used units where the overall water consumption is not so high. So let's have a look at how the system works. Okay, it's a lot of words here, but I'll summarize on the next page an overall image. But essentially, the system comprised of two elements. You see them on the picture here: a water collection tank skid and a sanitation skid. The tank skid is placed next to the homogenizer, and there it collects the used lubrication and cooling water. While that water is collected, the tank skid is continually monitoring the quality of the water, and that provides a preliminary assessment and treatment. As long as the water remains in tolerance for quality, then it's pumped to the sanitation skid. And in the sanitation skid, the water is filtered, it's sanitized with UV, and then it's monitored and cooled. That's to take out the heat that would have been generated in the homogenizer itself. The recycled water is then returned to the homogenizer. The system uses redundant water quality sensors to monitor for impurities. So in the tank skid, for example, we're monitoring dissolved solids, conductivity, and temperature. And when the water is outside of set tolerances, the system will reject it and then will continually supply the city or municipal water to the homogenizer instead of recycling. The redundant valves and programming methods are used to ensure that the homogenizer water supply is uninterrupted. So in practical terms, that means the valves are normally open so that if there's any kind of a fault, the system will continually supply fresh water, even if it can't recycle. And users have the ability through the automation interface to set alarms within the system, and those can be communicated in a number of ways, typically back to the plant control system, but there are a number of other options as well. So what's essential is that the system doesn't interrupt the water supply should there be any problem with the water itself or with a fault within the system. Here's an overview of how it works, which is perhaps pictorial form is simpler. So first, if we start with the homogenizer on the top and envisaging the water coming out of the homogenizer on the left side, that tank skid is collecting and screening the water and monitoring the water quality. So any out of water tolerance goes to drain. For example, if there were a packing leak and the water had milk in there, then you wouldn't want to try to recycle that water. And that's detected with the sensors in the tank skid. But in normal operation, of course, the water then would be pumped through to the sanitation skid. And in the sanitation skid, which is 75 feet away from the tank skid, you have dual filters and UV sterilization and cooling taking place. The sanitation skid also has the inbuilt PLC controls and alarms and the fail-safe connection to the process water supply. So whereas in the past the water would be connected directly to the homogenizer, now it's being connected to the sanitation skid to route through to the homogenizer. The important thing is that clean water will always be available and won't be removed from the system, so that your homogenizer has uninterrupted operation. So that's the simple overview. Obviously, the tank skid needs to be located close to the homogenizer to pick up on the water supply, some of which may be gravity fed and some of which would be pressurized. And that water supply is covering both the cooling water and the lubrication water on the typical homogenizer. The sanitation skid, as mentioned, can be further away depending on the space requirements. So that's the core of how the system operates. Some questions that are asked in terms of how does it get maintained and how does it integrate? So I'll answer those here. So first of all, in terms of the integration to plant control systems, yes, it can be integrated. The onboard automation system can output data such as system status and recycled water volume and faults via an Ethernet connection. Additional integration services to local control systems are available across a variety of platforms. And then in terms of maintaining and operating the unit, no special skills are required. Typical operatives in a process plant will be able to operate it without any problems. And in terms of maintenance, the filter changes are recommended every 3 months. Sensor calibrations recommended every 6 months, and UV bulb replacements are recommended annually. And again, no special training is required. So the system is going to be easy to operate and to live with. And of course, because of the onboard sensors and automation, it will diagnose faults within the system, in the control system. So that's how the system works and the overall setup. Let's take a look at some of the key benefits. So what value will this system bring? Obviously, reducing water is a good goal in itself, but in terms of the water reduction, it can recycle up to 97% of the water used by homogenizers. And the remaining 3% is water required for startup, for shutdown, and for some intermediate steps during the operating day. This provides significant cost-saving potential due to high water rates, whether now or in the future, and it reduces exposure to water availability challenges, whether it's quotas on water which can be drawn in the plant or additional costs based on thresholds of consumption. Second benefit is that it generates process quality water automatically. And the system has been designed and proven to meet or exceed pasteurized milk ordinance, PMO specifications for Category 1 water, and 3A standards. So the water quality is of the same process quality as you'd expect. The system is provided with fail-safe and redundant controls for continuous operation. Again, uninterrupted operation of your homogenizer. An additional benefit is the built-in homogenizer leak detection through the sensing of the water that's collected in the tank skid. And the system has the continuous water quality monitoring to ensure that the water is of the correct standard throughout the operating cycle. I'd mentioned the temperature control. Obviously, the system must also cool the water to take out the heat generated in the homogenizer, and that's done locally without consuming additional water. The plug-and-play integration, well, this system will fit APV plus other brand homogenizers. It's a compact system, we'll see the sizes shortly, and it has the self-contained controls. What's critical with the system is that it recycles and processes the water before it goes down the drain. So that removes some of the complications with traditional collection systems. So taking a look at some of the technical features, just highlighting some of the main points on the details on the left. It's a plug-and-play system, as mentioned. It's a stainless steel washdown construction. It's got its own onboard HMI and control capability. And we look at this as a black box, which can take care of all of the inbuilt controls, as well as communicating externally through the Ethernet port. It has the redundant water quality safety protocols in terms of ensuring a fail-safe supply of water to the homogenizer. It's equipped with sanitary quick fittings for the piping connections. And the cooling can be operated either from glycol or chilled water. Obviously, a range of voltages are available, and 3 models we'll look at a little later to explain the functionality. The system has a capacity of recycling up to 10 gallons a minute, or 2,200 litres per hour of water, and the 97% recovery rate. Then we see on the right the dimensions. That's based on the sanitation skid is just over 50 inches by 24, and the tank skid is around 32 by 21. So it's a relatively small footprint to fit next to the homogenizer. And as mentioned, where space is tight, the sanitation skid can be mounted up to 75 feet away. So how do we implement the system? I'll just walk through some of the factors to consider when looking at the HWRS. So the target applications here, and of course the first driver is water saving, but typically the maximum benefit are going to be where we have continuous processes with long running hours. Medium and larger homogenizers, they tend to have the higher water consumption. And then in areas where we have high water cost and water treatment cost. So then we'll start getting additional OPEX reduction benefits. The system is designed for non-sterile or non-aseptic homogenizer applications, where we don't need to think about sterilizing the water lines within the system itself. And it can be supplied with a new homogenizer or retrofitted to existing homogenizers of any brand. So very flexible in terms of where the system can be used. But the key driver in terms of application is really the desire to save and conserve water, and then look for areas in the plant where there are homogenizers, particularly, of course, where there are multiple units. So taking a look at the 3 models or the 3 configurations that we offer, and this is broken down into the single, which has 1 homogenizer connected. And in that case, we have 1 water recycling line going out to 1 homogenizer at 1 temperature. And the models here really depend on the number of homogenizers and the level of temperature control that's required. The next one is the S plus, single plus. And here we have 1 homogenizer connected, but there are 2 water recycling lines, each with a different temperature. So for example, where you want to have the lubrication and the cooling water at different temperatures. And finally, we have the dual unit. Here we can hook the unit up to 2 homogenizers. We have 2 tank skids and 2 water recycling lines to 2 different homogenizers, which can be at different temperatures as well. So for example, this could be convenient where you have 2 homogenizers located relatively close together, and then you can double up on the sanitation capacity within 1 unit, and it provides an additional cost benefit. So those are the model configurations, and when you send the inquiry to SPX Flow, then we look at the best configuration for your needs. So thinking then about the integration steps, how do we take an inquiry and assess whether this is the right system for you? So there's a number of steps which we'll take. Firstly, we will ask you to complete a requirements questionnaire. That may look at the homogenizer model and the current utilities consumption data. And very often we find that the actual consumption is higher than the nominal consumption for a number of reasons. So the water consumption may even be higher than you might think based on the homogenizer data. And then if the initial findings look interesting, then we would ask for a site survey, either by ourselves or one of our partners. And in the survey, we'd look at the layout, the available space, the cooling media available. We'd look at a location where it could be mounted. That should be 75 feet away. We would identify interconnecting piping and wiring routes, and then controls and communications to the customer's PLC. But your SPX Flow representative will be able to review the details then and prepare the offer. So it's not a lot of information to collect, just to ensure that we can assess the suitability. And then after we've done that, we would come back with an offer. So now coming back to that initial water consumption, I want to share an investment example. And here again, we have the first half of the table that we looked at earlier. And I'm showing the small to extra large and older homogenizers with the consumption from 0.9 to 5.3 gallons a minute. And then we have the average annual water consumption based on 20 hours a day, taking the higher case, again, up to 1.8 million gallons. And then taking a range of water costs from $11 to $19 per 1,000 US gallons. That's covering the water and sewage costs. You can see the payback begins to become interesting when we get from the medium to large, and particularly when you get to the extra large and older machines. Of course, each situation is different, and the water costs particularly will vary as well as the consumption. But this example highlights that the volume of water and the cost of water can really be impacted by installing this unit. Of course, by installing a dual unit where two homogenizers are served by the single unit, then we'll almost have the payback benefit. Again, each situation is different, and the driver for water saving, of course, will be an important factor as we look to the suitability and the interest level in the unit. So summarizing some of the key takeaways. This is a groundbreaking technology. It's enabling water saving on homogenizers in a way that hasn't been done before. It scales down the technology for water recovery and sanitation and focuses on the benefits for homogenizers. It allows you to start thinking about saving water and money now, and just thinking about that volume of water that's consumed. There's a potential here to save millions of gallons of water. Not only good for your pocket, but good for the environment and can help with your sustainability goals. You can contact your SPX Flow representative or local distributor or channel partner for more details, or you can visit our website where you'll find more information on the system itself. Now we'll look at those questions and that you may have had during the presentation. Will take some time. You can always contact myself or our regional North American sales specialist, John Van Cray, details shown here, to get more information, as well as through our channel partners. Okay, so now we're going to take a look at some of those questions that have been raised, and thank you for sending those in. Please continue to type in the questions in the Q&A panel if you can. Hopefully I'll be joined now as well by John Van Cray, whose name you see here. And John's going to support on answering some of these questions. So, hi, John. So, in no particular order, I see a number of questions here that people have put in. So, first question is, can it be used on multiple homogenizers connected to a single unit? Yes, it can, in fact. You saw perhaps later in the presentation, after the question was raised, that we have the dual unit which hooks up to two homogenizer systems. We do get asked from time to time, why not more homogenizers being hooked up? And that's really around the integrity of understanding if there is some kind of for example, a packing failure on one, you don't want to have the whole system down, and it enables the control and the integrity of the system to be preserved. So thank you for that. That's a good question. So another question is it standalone, or what? Do you have to supply glycol or chilled water? John, do you want to take that one?
I'm sorry, what was the question?
Question on what the utilities are to support it, whether it's glycol or chilled water.
Oh, it could be either.
Yeah. Basically, you just need a cooling source. Exactly.
Source, yeah.
Okay. What else we got? Okay, so good question here from somebody asking if it works on aseptic homogenizers. Another question that we do get asked a lot. So right now we're marketing this for non-aseptic, non-sterile, or non-downstream homogenizer applications. The core technology will work absolutely fine. But if you think about some of the additional elements of an aseptic homogenizer, where you're sterilizing the plunger lubrication area, and you need to do steam sterilization typically of that area. So that places a whole additional requirement on the lines and on the components. And so that's not the target at the moment of the system. The system works on homogenizers that use potable water, which doesn't have a sterilization step for before startup. So thank you. That's a good question. Let me see here. Yeah, we talked about utilities. Oh yes, so a good question on the ROI and whether the electrical consumption is factored in. Yes, it is. So the consumption is based really on running the pump, and the instruments obviously won't require a lot of consumption, and the UV lamps. So the consumption from memory, it's in the range of less than half a kilowatt. I need to double check that, but that's the range that we're looking at. But it is factored into the ROI. Thank you. So what else have we got? So a question on whether data sheets are available. Yes, we do have a web page where there's a brochure with some additional information available. And when you get an offer from us, then you will get also the additional technical information as well. So thank you for that. So keep the questions coming. We answered on utilities. I think thanks, Randy, for a question on whether it's just fresh water and electricity. Well, it's not fresh water in the sense that you require the fresh water as the backup supply, but it's electricity and a cooling source, whether it's glycol or chilled water, and in the fresh water for the top up, and in case there's any fault. Okay, just going to pause here to see if we're what other questions we have. Keep them coming in. Okay, there's a question here on whether we've thought about pumps. Really good question. Again, that comes up from time to time. So right now the system is configured for homogenizers, as we've presented here, but we are looking at opportunities either to condense the size to make it smaller and look at recovery of water and pumps, or whether it could be integrated in some way for pump water to be collected as well. The requirements are slightly different, of course. You don't have the same heat load, for example, typically, but on the other hand, there's more complex distribution to get around to your pumps and to collect the water from the pumps. But I guess when you go into most plants, for every one homogenizer, you see a lot of pumps. So there's a lot of opportunity there, even if individually the water use is relatively low. So watch this space, more to come on that from us at a later time. And then there was a follow-up question on the ROI asking around aseptic homogenizers. So as mentioned, we're not targeting aseptic homogenizers where, of course, the steam load is going to be adding to it as well. Okay. Okay, it's a question on RO water being incompatible with tungsten carbide homogenizing valves, and that the water is filtered in the system. Does this affect the tungsten carbide valves? No, not at all. In fact, the water won't be touching those valves typically because it's only used for services in terms of the cooling and the plunger lubrication. But the filtering inside is not, it's a physical filter, a micron, 1 micron and 5 micron filters. So that won't have any effect on the water itself, other than removing any impurities that might have come in there. So, okay, thank you for that question.
Con, I don't think there's another question I don't think got answered. This can be used for all different industries. So food and beverage and dairy are probably the top for us. But, you know, as long as it's a fairly clean environment in the plant, if it's a nasty environment, it might not be suitable, but it could be used in an industrial application as well as chemical.
Thanks, John. And I think an important point, and we touched on it in the presentation, I know some of you attending are in sales, and some of you are, are users, if you like, producers. It's really around what's driving the desire to conserve water as well, and that can vary depending on the industry. And so that's an important factor, I guess, in terms of looking for ways to conserve water. And we feel this is an important one. In the sanitary industries, the drivers are perhaps higher in some cases, but nevertheless, for industrial applications, there are also uses. It's just that some homogenizer applications in industry don't require water lubrication. They may use oil or solvent or some other things, and the system isn't designed around that. Okay, there's a question around if the presentations will be available for anybody who joined late or wasn't able to join. Yes, of course. After leaving, in fact, anybody who's registered will receive a link to this presentation, which is being recorded, which I believe was informed as you came in. So no problem with that. There's a question on whether there's a case study available that could be shared with customers. We do have references. We haven't quite crafted them into a case study, but we could certainly look at doing that if that would help. I should also add, actually, that for those interested in, how quickly we could move on this, we do have inventory of the units available in each configuration at our facility in Delavan, Wisconsin. So we're ready to move quickly for anybody who would like to start saving water and to validate it in their own situation. So thank you for those questions. Okay, let me just check here in case there's any coming in on the other window. Okay, got most of them. So, all right, if there's any other questions to come through, just one of the questions that comes up from time to time is in terms of the physical integration. And as many of you know, the water doesn't always exit an homogenizer under pressure or at height. So one of the questions that we get is, how do we collect water at low level? And we do have an additional sort of sump valve arrangement that allows us to collect water that's discharged at a low level. So it really depends on the physical installation. But that tank skid is very compact and can sit right next to the discharge points, whether pressurized or under gravity. Okay. All right, I think we've answered that one. John, am I missing any? I think we've covered.
No, I think you've covered all of them that I saw.
That come up on the panel. All right. So, John, anything you would want to add? And just while we wait, in case there are any other questions, anything?
Well, I do want to reiterate that, yeah, we are really marketing this for the larger and medium-sized homogenizers that are running around the clock. The return on investment is so long on the smaller machines and the ones that only run 8 hours a day. it's really to any salesman's advantage to start asking those questions at the very beginning. You know, how much water do they use is a pretty critical question, and how much is their cost for sewer and water rates.
That's a fair point. I think what we've seen as well, and I'm sure many of you will know that, you know, no matter what the water consumption on the data sheet or on the spec sheet for the homogenizer is, very often they're consuming more. The real life usage may be more. So the opportunity to save is best judged by actually going out and measuring it. You know, just take that measurement. It's not often even hooked up to instruments. And then, as John mentioned, the actual local cost then will determine. So the payback really depends on those factors, and of course the running hours. There's a question on the price range, and so what I'd ask is contact us with the details of the water consumption of the homogenizers you have, and then the system configuration will give an indication. In the quote, obviously, we'll give the price range. But as John says, the most, you know, the more water that's used, then the more that will be saved. And I think, you know, I suppose related point on the ROI and generally on the investment. I think I might have touched on it earlier in the presentation as well. I think if this were easy, it would have been done in different ways. What this system brings is that integrity of taking care of the sterility, or let's say the process quality water on a continuous basis, and not just recirculating water and waiting for it to, you know, maybe build up some levels of particles or other matter. And so that's really why the system is designed as it is, to take care of both streams of water within the homogenizer in a safe way. Okay, so let me just check here. No, I think that's all the open questions. Have we got any others that came through the chat? Don't think so. So at that stage, I guess if there are no other questions, really appreciate. I know it's a lot of people who've joined today. This is new. It is different. There's some learning, and we're working with our channel partners and their teams to support the conversations around that. Because there's nothing like this on the market at the moment. It's not a conversation that perhaps has been possible before, but the integrity, the automation, the instrumentation, and the sterilization with the UV light all built into the system, that gives the confidence that the system is going to give that process quality water every time. And should there be any sort of a fault, alarm, packing leakage, whatever, then it's going to revert to pulling in your municipal water, so without interrupting. So we really look forward to having some of those conversations with you. As I mentioned, we have units ready to ship. So if you have customers, if you are a user who would like to try this out, talk to us. We'll be really happy to talk to you and to share our experience. And with that, if there's no other questions, John, I think, unless I'm missing anything, we look forward to those conversations. And thank you for joining us today, and have a good rest of your day.